Good day, sir, and good day, everyone. We are the What's Minene group from Bachelor of Science in Electrical Engineering, third year, Section C. And I am Ashley Liel Manyo. So in this video, we are here to discuss the topic about solar-powered home. First, ano nga ba ang benefit if we are going to install a solar-powered setup sa mga bahay natin? If we are located in a city proper, kapag maayos yung pagkaka-install ng solar system setup, makakatipid ka sa pagbabayad ng kuryente. And on a greater side, pwedeng wala ka ng bayaran. So, paano nga ba natin ma-achieve yung benefit na makakatipid? So, we will discuss it here. So, here are the three configurations of solar-powered home. First is the grid-tied. A grid-tied solar power system is connected to the home and the traditional electricity utility grid. This type of solar power system does not include any storage battery. So, it is directly connected sa electrical circuit sa ating mga bahay, which get its power sa utility grid, and it has no battery backup. And the next is off-grid. This type is a standalone system that is completely disconnected from the electric power grid. It contains a large set of battery packs which stores energy during the day to be used at night or at times when sunlight intensity is low. This is completely isolated from the grid. So kadalasan ginagamit yung off-grid setup kapag meron kang bahay sa bundok or sa mga lugar na walang supply ng electricity. And being a standalone system, ang off-grid setup ay kailangan niya ng may battery backup to serve as a source of power kapag gabi or at times when sunlight intensity is low. And then last is hybrid. A intertied solar power system is also connected to the traditional utility power, which contains battery backup. The addition of a battery backup enables the system to work when there is power interruption. So, sa hybrid naman, it is combination of grid-tied and off-grid. Connected siya sa grid and at the same time, meron din siyang battery backup. So next slide. Solar-powered home, grid-tied. So when it comes to solar-powered home, our line of concentration is the grid-tied setup. So we will discuss it further. So in a grid-tied type, the solar power system is being connected in parallel to the electric supply that goes inside the house and only function during the day. Any excess energy that is being produced is then fed into the grid. So any excess energy that is being produced is then fed into the grid. Since there is no battery backup, it does not produce power at night. And then during brownout, the solar power system is also in a shutdown state, hence does not produce electricity. Its main purpose is to save electricity. In fact, when the solar array's rating matches the electric consumption, zero bill can be attained. And when solar array ratings exceeded the day and the night electric consumption, the system will be able to produce excess power which will be paid by the distribution utility. So kaya sinasabi dito na only function during the day, since wala siyang battery backup. So kumukuha lang siya ng energy from the sun pag daytime, and pag nighttime naman, yung system ay shutdown lang. And then dito naman is during brownout, another major disadvantage to ng grid-tied setup. So kapag nag-brownout, automatic advantage siya ng grid-tied setup So kapag nag-run out, automatically na yung inverter is shut down the whole system. And then sinabi din dito na zero bill can be attained. Pwedeng wala nang bayaran na electricity bill and pwede pang wala ka nang babayaran, and also kukonti or bababa yung babayaran mong electricity bill sa distribution utility. And then pwede din na ikaw pa yung bayaran ng distribution utility. And then next, here is the illustration of any excess energy. So dito pinapakita lang dito na yung any excess na energy that is being produced is then feed into the grid. So paano nga ba yon? So eto nga yung grid natin. Eto. So yung grid natin, powered by grid-tied solar system. For example, yung solar panel na to, halimbawa ay nag-generate siya ng 300 watts of power ngayon. Yung load mo 2,000 lang. So ang excess ay 1,000 watts. Yung 1,000 watts na yon, mapupunta lang yon sa grid, dadaan ng metro, and then yung metro palabas at papasok na kuryente, nagre-register sa kanya. So ngayon yung excess na 1,000 watts, pumapasok pa yon sa electricity bill mo. So pinapakita lang dito sa illustration na to na nangyayari yung ganyang scenario sa grid-tied system, which is worst case, pero di ba sabi nga main purpose ng solar panel is to save electricity and zero bill can attain. Pero bakit nga ba nagre-register pa sa metro mo yung excess power na nage-generate ng solar panel mo? So hanggang dun na nga lang muna i-discuss natin sa mga susunod pang slides. And we are going to discuss what we should be done in order to avoid those worst case scenario. The next. So we are going to discuss this further. So this is the solar powered home grid tied basic parts. So first is solar panel, grid tie inverter, which has with or without limiter, and then square wave or pure sine wave. And then DC circuit breaker, DC surge protection device, and then AC circuit breaker, AC surge protection device, time delay switch, DC or AC electrical wires, and then yung MC4 connectors, solar rail, and then clamps. So we are going to discuss it further pa, except lang sa tatlong smaller parts, which is yung MC4 connectors, solar rail, and clamps. So next. So solar powered home grid tied parts and function, solar panel. So the heart of solar powered home, a typically solar cell will only produce around half a volt. So by connecting them together in series inside the panel, a more useful voltage is achieved. Most small solar panels rated 150 watts or below are rated as 12 volts, while larger solar panels are 24 volts. A 12-volt solar panel produces around 14 to 18 volts when put under load. This allows a single solar panel to change up a 12 volts battery. Incidentally, if you connect a voltmeter up to a solar panel when it is not under load, you may well see voltage readings up to 26 volts. This is normal in an open circuit on a solar panel. As soon as you connect the solar panel into circuit, this voltage level will drop to around 14 to 18 volts. The next, solar panel connections. So solar panels can be connected together to create a solar array. The output of a solar array is computed much like a battery. Series connection increases the voltage while current remains the same. And then parallel connection increases the current while the voltage remains the same. And when you connect multiple panels together, the power of the overall system increases, and regardless of whether they are connected in series or in parallel. So since the solar panel is generating a direct current nga, so it is comparable to the battery. And then, so ano nga ba yung mga connection regarding sa battery? So you can connect it sa series and parallel or combination of both series and parallel. So here's the example, certain problem. Each panel on the next slide is rated at 12 volts and 10 amperes. Calculate the following: total voltage, total current, and total power. So this is the solar panel connection. So illustration of of series. So again, is a series connection. The primary aim is to increases the voltage while current held constant. So this one is the connected in series. This one. So the final voltage and the current output as well as the power of this connection is here. So yung sa series natin is 36 volts and then 10 amperes. So the power is V times I, or current times the voltage. So it is 360 watts. So sa parallel naman, the primary aim of this is to increase the current while the voltage held constant. So dito naman, the final voltage is 12 volts and then 30 amperes, and then 12 times 30 is 360 watts then. So next, dito naman kapag hindi pumapasok yung characteristic ng load sa series or parallel, so dito na papasok yung combination of both series and parallel. So here the final voltage is 24 volts and 20 amperes. So 24 times 20 is 480 watts. So kagaya lang din siya dito sa last illustration. Nakatayo lang siya. So yung number 3 and number 4 is magkamukha lang, nakatayo lang siya. So it has 24 volts then, and then 20 amperes, and with the 480 watts. So pinatayo mo lang kaya yung output will be the same. So dapat alam natin kung ano yung dapat natin gamitin at yung principle kung kailan natin kailangan na i-series or i-parallel ba or gumamit ba ng combination of series and parallel. And then next. So, kailangan alam din natin kung ano yung pagkakaiba ng dalawa na yan. Yung polycrystalline versus monocrystalline. So, yung mono, to make cells for monocrystalline panel, silicon is formed into bars and cut into wafers. And then yung poly, to make cells for polycrystalline panels, fragments of silicon are melted together to form the wafers. So sa next slide, we will discuss it further. So ayan. So when it comes sa silicon arrangement ng monocrystalline, one silicon crystal lang siya. And then sa polycrystalline, many silicon fragments melded together. And then when it comes naman sa appearance, panels have black So, kulay black ang monocrystalline natin. So, ayan, kulay black. And then yung polycrystalline naman natin is color blue. And when it comes naman sa efficiency, more efficient ang monocrystalline. And then less efficient ang polycrystalline. And then when it comes naman sa lifespan, 25 to 40 years ang mono and 20 to 35 years ang poly. So mapapansin natin na mas matagal ang lifespan ng mono. And then when it comes naman sa temperature coefficient, sa monocrystalline, lower temperature coefficient, so making them more efficient in heat. And then sa polycrystalline naman, high temperature coefficient, making them less efficient in heat. So, mas suited sa Pilipinas ang monocrystalline dahil nga mainit ang klima natin dito and mas maganda ang mono kapag i-consider mo yung performance and efficiency niya. So, mas magandang piliin o gamitin ang monocrystalline. Pero ano nga ba ang advantage ng polycrystalline? Yung polycrystalline naman, advantage niya is pagka nagtitipid ka, wala kang budget, mas mura ang polycrystalline. Pero mas maganda gamitin ang monocrystalline kapag may budget ka. Dahil mas matagal ang inaabot niyan at mas maganda ang performance at efficiency. And then next. So dito naman tayo sa parts and function ng inverter. So dito, pinapakita lang yung illustration ng inverter. Yan yung example ng inverter na mahal at mura. So, meron tayong mga inverter na mas mahal, meron tayong inverter na mas mura. And then yung inverter na yon, nakadepende yun sa preference mo kung ano yung gusto mong inverter pagdating sa appearance, dun ka medyo mamamahalan dahil sa appearance. Pero pag gusto mo lang ay mura, kahit na pangit lang yung appearance, pwede na yon. Then next. So inverter converts the DC output of the solar panel into AC, which is the standard used by all commercial household appliances. Hence, the inverter output matches the voltage within the house that is coming from the grid. Traditionally, there is usually one central inverter in solar system. A more recent invention has been the microinverter. Microinverters are connected to individual solar panels so that each individual panels provide a high voltage alternating current. This setup are typically used only with grid tie systems. Though costly, they do offer some significant benefits over the more traditional central inverter. A grid tie inverter unique characters over the other types is if automatically shut down the system when there is a power interruption. So as we all know, yung inverter ay device that convert DC to AC in the AC or direct current to alternating current. Kasi nga yung mga bahay natin, AC yung ginagamit dahil yung mga appliances natin uses an AC. Kailangan ng inverter dahil nga yung solar panel natin ay nagge-generate siya ng DC output. So dito naman sa highlight, dito yung recent invention na microinverter. Yung microinverter natin na setup ay yung sa bawat isang panel may isang maliit na inverter. Mas mahal nga lang siya pag pang may budget lang siya or pag may kaya lang na bilhin yung ganito dahil mahal siya. Dahil nga madaming maliliit na inverter ang kailangan mo na ikakabit mo sa bawat panel na ilalagay mo. Pero may advantage naman siya dahil mas efficient naman yung buong system than the traditional na isa lang yung inverter. So dito naman, kapag may power interruption, automatic siya. Yung grid tie inverter, yung unique characteristic niya is automatic siya na nag-shutdown dahil kapag hindi siya nag-shutdown, posible na mag-produce pa siya ng power ng nagaling sa solar panel mo galing sa solar panel mo sa bahay na mapupunta pa siya sa grid or sa metro. And then next, the pure sine wave inverters. This type output voltage in the form of sine waves utilize also provide sine wave output. Because of these, pure sine wave inverters are usually needed if you're going to be tied to the grid. Typically, you'll need pure sine wave inverters for sensitive equipment. Newer TVs, CFL light bulbs, and appliances with AC motors, microwaves, and refrigerators. So pure sine wave inverters are capable of producing cleaner, smoother, quicker, and more reliable electricity to operate appliances and electronics without interference. So Raygon sells a range of pure sine wave inverters of varying capacities to fit your solar installation and your energy needs. So that is the first type of inverter. And then the second type of our inverter is the modified sine wave inverters. In pure sine wave inverters, the AC power produced by the inverter very closely matches an actual sine wave. In modified naman, sine wave inverters, the polarity abruptly switches from positive to negative. When looking at the wave, it has a straight step, square pattern where the polarity is flipped back and forth. I love my life that choppy wave can negatively affect more delicate, sensitive equipment. If you have medical equipment, you need to power, such as CPAP machine. You won't be able to use a modified sine wave inverters. Additionally, in many cases, you'll hear a hum with devices attached to a modified sine wave is that this is much cheaper. So, ano nga ba yung pagkakaiba ng two types of inverter natin? So, kapag kinonect natin sa oscilloscope, yung dalawang types na to, yung pure sine wave and modified sine wave, ito yung makikita natin na wave sa inverter. So, ito yung pure sine wave sa left side, and then ito naman yung modified sine wave sa right side. So, sa modified sine wave nga is may mga hum na naririnig tayo. And then, so kapag pipili ka sa dalawa, kung pure sine wave inverter, or modified sine wave, ang mas pipiliin mo ay yung pure sine wave. Bakit? Kasi yung mga new technology ngayon, hindi na kayang paganahin ng modified sine wave inverter natin. Pero kung talagang wala kang budget or sa mga loads mo lang ang loads mo lang is mga lights, light bulb na may hina or mga older appliances, pwede na si modified sine wave. Pero may sasuggest ko is yung pure sine wave dahil sa mga bagong technology ngayon, mas kaya niya nang mapaandar dahil mas high-tech na siya and mas malakas ang efficiency ng pure sine wave inverter.
This is the example of the DC circuit breaker. DC circuit breaker. The DC circuit breaker, sometimes referred to as the PV disconnector, were placed between the solar panel and the inverter, or in some cases, built into the inverter. Just like a typical CB, it acts as an overcurrent protective device. Short circuitation, the part of the solar array may produce a high value of current, which might damage the inverter or the system as the whole. Before it happens, the DC circuit breaker acts as an automatic switch disconnecting the inverter from solar array. It also serves as a manual switch if there is a need to turn the solar power system off or isolated the solar panel from the rest of the system. So, a DC circuit breaker is an OCPD that protects electrical device operating with DC and contains additional arc extinguishing measures. DC circuit breaker are relatively new technology to most homeowners since most devices used in-house work in AC and DC circuit breaker. If the system uses the battery bank, it must also be protected by a DC circuit breaker. The inverter, which converts direct current to alternating current, requires DC circuit breaker at the source. Finally, if the user has an exclusive electric panel or DC loads, an array of DC circuit will be required. AC circuit breaker or RCBO type. As the AC circuit breaker are placed after the inverter. Just like a typical CB, it acts as an overcurrent protective device due to short circuit and overloading. RCBO stands for residual current operated circuit breaker with overcurrent protection. In the RCBO type, it has added protection since it can sense earth leakage current where the typical breaker cannot. It has the capability to trip when somebody touches a live wire, thus protecting the protecting around it. It may also serve as a manual switch if there is need to turn the solar power system off. So dito naman sa may AC circuit breaker naman, inaano lang dito yung a safety switch na nagpo-protect sa equipment from damage by turning off the power when overload. When you overload ay detected. Ganun. It also protect daw yung safety since yung overloading circuits can result ng fire or sunog. So yung naman, yung circuit breaker box naman o yung gray metallic box is usually located siya sa mga areas na katulad ng garage, basement, closet, laundry room, ayan. Or yung mga exterior na part of your home. Just like switch that is tripped, meaning that it's moved to neutral position. So this is the example of AC circuit breaker or RCBO type. So dito naman tayo sa DC, SPD are placed parallel to the DC to CB. So yung SPD generally protects the system from power surge or more appropriately called voltage transient. SPD redirects this access power to the ground. In PV systems, since solar panel are heavily exposed in the environment, transient voltage is primarily caused by lightning either directly or indirectly. Multiple interconnection within power cables is very susceptible to electromagnetically induced transient where power surge could also arise. Yung transient voltage is the occurrence of high voltage in a very short duration of time, around 10 to hundreds of microseconds. Yung exposure to this transient voltage may cause catastrophically component damage leading to system failure. So dito naman ay tinaanan natin yung electrical system, surge protection device or yung SPDS ngayon. Usually installed siya sa naka-installed in top of yung configuration or yung naka-parallel between the live conductors and the earth. The operating principle of the SPD can similar to that of the circuit breaker. So may tinatawag tayong in normal use o yung ibig sabihin is no over voltage. Meaning yung surge protection device is similar to an open circuit breaker. Kasi isa naman yung over voltage naman, yun yung surge protection device naman magiging active and discharge sa lighting current sa earth. So yun. So ito yung example ng AC surge protection device. Ayan. This is another example. So then another example din siya. Ayan. Makikita nyo sa part nito, sa part niya ay merong positive and negative. Napareho lang din siya ng voltahe. Yung niya is 600 volts. Ayan. Pareho lang siya. So dito naman tayo sa AC surge protection device. Yung AC SPD are placed parallel to AC CB. Just like the DC SPD, these serve as protection against transient voltage, but this time on the AC side of the PV system. SPD redirects this excess power to the ground. Multiple equipment connection on the grid, either internal or external, can also be cause of electrical anomalies where power surge could also arise. So dito naman tayo sa surge protection naman no SPD, yung yung component niya, yung component of electrical installation protection system, yung device nito is connected siya sa parallel ng power supply circuit of loads that has to protect. It can also use at all level of power supply network. This is the most commonly used and most efficient type of over voltage protection. So itong SPD is connected siya sa parallel ng high impedance or impedance na once na yung transient voltage ma-appear sa system, yung impedance niya of the system i-decrease siya. So yung surge ng current is driven through the SPD by passing the sensitive equipment. O yung mga mga sensitive equipment katulad ng mga TV, yung mga appliances, yun yung mga example ng mga sensitive equipment. So ito yung example ng time delay switch. So ano yung time delay switch? This can also be called as power on delay. It delays the turning on any electronic device for desired time interval. This device serves its useful purpose usually when brownout occurs. After a brownout, when power have already been restored, there is the tendency of the power surge which may damage the system. If it is being turned on right away to prevent this time delay switch delays the turning on the system for a minute or even a bit more. So dito naman yung yung circuit naman in which output signal is delayed by a specified time interval with respect to input signal, also known as delay circuit. Yan. So ano yung purpose ng time delay switch or time delay relay na yan? So itong time delay relay na yan are simply controlled lang ng relays na with time delay built-in. So yung purpose niya is to control an event based on time. Halimbawa nag-brown out, yung mga katulad yung mga sensitive equipment na kapag nagsasudden na namamatay or biglang nauhugot, nasisira. So dito naman meron siyang minute bago siya para kung halimbawa na lang yung computer nag-brown out. 'Di ba pag nagsudden na mapatay yung computer natin is pwede masira yung mga SDD, HDD. So dito naman pag nakasaksak siya sa time delay switch, pag nag-brown out, meron pang minute na pwede mo siyang ma-turn off para hindi masira yung computer natin. So ito naman yung programmable timer switch. So ano yung programmable timer switch? Turning the solar power system on and off could be a vital routine which cannot be perfectly done in a day-to-day basis. A programmable timer is a hassle-free switch to automatically turn the system on and off of your desired time. So ano yung programmable light switch timer? So itong programmable timer switches na to are used to automatically turn lights on o kaya off at the set time. There are optional naman na settings for daylight saving time and sunrise or sunset adjustment, making them perfect for porch lights and landscape lighting, so you can set it and forget it. So dito naman halimbawa sa garden natin, automatic siyang mag-o-open kung alam niyang day-night na. So hindi mo na siya pipindutin, naka-timer na siya. O halimbawa naman, nag-umaga na, automatic din siyang nagsi-switch off. Yun.
Yung screen ko black yung. So, solar power home. Next. Next slide. What is the net metering? Net metering allows customer of distribution utilities to install an on-site renewable energy facility not exceeding 100 kilowatts in capacity. So they can generate electricity for their own use. Electricity generated that's not consumed by the customer is automatically exported for the DU's distribution system. The DU then gives a peso credit for the excess electricity, receive equivalent to the DU's blended generation cost, excluding other generation adjustment and the credit earned to the customer electric bill. So ang net metering ay isang electricity policy for consumers who own yung mga mga solar power home, yung mga which allows them to use electricity whenever needed while contributing their production to the grid. Next slide. Is net metering already available in the Philippines? On 27 May 2013, the Energy Regulatory Commission ERC Resolution 09 series of 2013 approving the rules enabling the net metering program for renewable energy. This resolution was published on 10th July 2013 in newspaper of general circulation in the country and look effect 15 days thereafter. Thus the net metering rules look after in the Philippines on July 24, 2013. The net metering is available only to on-grid distribution system. Next. What benefit will I get if go into the net metering? By generating electricity for own use, you reduce the amount of electricity you buy from your local DU. The rate of savings or avoided cost, system loss on electricity generated for own use is equivalent to the DU's retail rate consisting of charges for generation, transmission, distribution, subsides, taxes, and other charges. You also earn peso credits on any excess electricity exported to the DU equivalent to the DU's blended generation cost, excluding other generation adjustment. The peso credits earned is then used to reduce your electricity bills. So yung mga ano dito, mga benefits ay nakapagbawas ka nga ng electricity bills. Tapos naka-benefit pa siya sa environment. So no need to install expensive battery storage system. Tapos nakapag-take some pressure of electric grids pa siya. Tapos nakapag-encourage siya ng customer to move towards the renewable energy. Tapos nakapag-preserve pa siya ng natural energy resources. Next. How will my DU meter may import or export energy? The DU may opt to install two meter, one 2 meter energy you buy from your local DU, and the other meter energy you buy from your local DU, and the other meter to energy you export to the DU. The DU may it's been installed a single bidirectional meter that can meter both import and export energy if it finds to be a more economical. The DU may install a third meter in proximity to your RE facility to meter its total RE generation. The total RE shall earn for the host DU RE certificates which the DU can use to comply with its renewable portfolio standards obligations. Next. So, question number 5. Who are qualified to participate in the net metering program? So, DO customer who are good credit standing the payment of their electrical bills. So, ito yung mga customer na lagi nagbabayad or on time lagi nagbabayad ng mga electrical bills. To their DU are qualified to participate in the net metering program for renewable energy. Those customers referred to in the rules as qualified end users or QE. Next. In case that solar power system is being installed and doesn't apply for net metering, any excess energy that is being fed to the grid will be billed to the customer. Example is when the system is rated at 5 kilowatts and the load consumption is only 4 kilowatts. The system will have an excess of 1 kilowatts which will be sent to the grid. This excess energy will pass through the meter ends, will be billed to the owner. Next. So another question is there any other way beside net metering that a customer having a solar power system producing excess energy during the day and yet will not pay for it? The answer is yes. So this can be achieved by using an inverter with limiter. This device limits the power that the system will dissipate. It automatically detects the maximum power that the system can provide without excess being sent to the grid. Next slide. So number 1 tayo sa wire sizing. So number 1 TW. Thermoplastic wire, moisture resistant and flame retardant. So yung mga ganitong wire, ginagamit siya sa ginagamit siya madalas sa mga machine tool wiring and internal wiring of appliances. Next. So number 2 is THW, thermoplastic heat resistant wire, moisture resistant and flame retardant. So yung mga ganitong wire naman, nagamit siya madalas sa So yung mga ganitong wire, ginagamit siya madalas sa mga building wire, feeder and branch circuits, at saka sa mga internal secondary industrial distribution. Next. So THHN, thermoplastic high resistant nylon coated, designed for specific installation material, temperature rating, and condition of use, suitable for dry and damp location. Next. So number 4, THHN or THWN. THWN is similar to THHN except it is water resistant. So yun nga po yung pinagkaiba nila. Yan po ay water resistant. Adding the W into the acronym THWN is rated for up to 167 Fahrenheit or 75 Celsius in wet environments, but its successor THWN2 is rated for 90 Celsius in both wet and dry environments. Historically, THHN and THWN were separate words, but now you'll typically find their capabilities combined in the THHN and THWN2 design. Next. So note, here's a breakdown to help make some sense of the lettering. The T stands for thermoplastic insulated cable. A single H means the wire is heat resistant. So HH means that the wire is heat resistant and can withstand a higher temperature. The added W signifies that the wire is also water resistant. Next. So PV wires. This type is an exclusive kind of wire created for PV applications. This cable behave extremely well in very hot temperature and other harsh environment conditions. Its special characteristic compared to other wire is its insulation and outer shell, which is made up of XLPE or EPR. So yung XLPE ay isang acronym for cross-link polyethylene, and XLPE is a thermosetting polymer, meaning that the material polyethylene PE is cured under heat and in that process forms in bonds in all directions, forming a three-dimensional matrix. EPR means ethylene propylene rubber. Next, last slide. So, solar power home. So, ito yung mga sukat ng AWG cable wire size. So, ang AW or isa tong American wire gauge is the US standard measure for the diameter of electrical conductors. So, yung AWG chart is based sa mga number of dies originally required to draw the copper down to the required dimensional size. It means the higher the AWG number is, the smaller the wire diameter is.
So before we proceed on my part, let me first discuss the circuit connection. Okay, so how the solar panel, the electricity generated from solar panel will be put into the AC load. So paano ba siya magamit sa ating bahay? Okay. So yung solar panel natin is magpo-produce or magkukuha siya ng electricity from the sun. Okay? So from solar panel, dadaan yon sa ating DC MCB, or which means the DC miniature circuit breaker. So this direct current or DC controls our circuit applications, which is used for current protection within appliances or electrical equipment. Okay, so as you can see, we have three miniature circuit breaker here. So, yung una natin dito is pupunta siya sa ating charge controller. So, si charge controller is yung bibigay or maglilimit sa mga nag-gather natin na electricity. Okay? So, meron din dito tayo tinatawag na DC load. Okay, so yung DC load naman is a test equipment that can measure values such as voltage, current. So, paggagamit tayo ng DC load, it can help protect valuable circuits and prototypes by providing accurate testing and system evaluation. Okay, so from here, from uh, solar panel, dadaan sa DC MCB, at dadaan din sa charge controller, and then may pupunta dito sa ating DC load. And then after that, dadaan ulit sa DC MCB, which is dediretso sa ating battery. Okay, so bakit kailangan ng battery? So, syempre, solar panel siya, kailangan, kaya niyang meron tayong, sa mga nag-gather natin ngayon, merong storage, di ba? Hindi naman pwedeng puro palabas lang or puro papunta. Kailangan na i-store pa rin dito sa ating battery. So, kailangan may battery ang ating solar-powered home. And then next, it will also go into, dadaan siya dito sa ating DC-MCB and then didiretso sa ating inverter. So, yung inverter, it converts our DC or direct current electricity, which is what a solar panel generates to our AC or the alternative or alternating current electricity, which the electrical grid uses. So, after dumaan dito sa ating inverter, pag nakadaan na siya sa inverter, ang tawag na doon sa susunod ay yung AC-MCB. Okay? Okay, so after dito kay AC-MCB is pupunta na siya sa outlet natin, sa AC outlet na tinatawag. Okay? So, yung AC outlet na to, common na yan, makikita na yan sa mga bahay-bahay natin. And, halimbawa, itong nasa AC load natin, yung electric fan, di ba? Merong mga, kailangan, para gumana yan, maisaksak natin siya or may input natin siya dito sa ating AC outlet. So, from solar panel, may mga dadaanan siya na tatlong DC-MCB and dadaan sa charge controller, sa DC load para matest. And then, syempre, kailangan ng battery. And then, pupunta sa ating inverter, dadaan sa AC-MCB, and of course, sa ating AC outlet para gumana or mapagana niya na yung nasa ating AC load. Okay? Okay, so now let's discuss the different tables that we are going to use in computing the copper wire size within the photovoltaic system. So this table is for, as you can see, the insulated conductor capacities. As you can see, there are tables for aluminum and of course on the copper. So what we mostly use is the copper. Okay. So, ito ay isang lang din yan. Parang another table lang din. Okay, so this is the table 310.15, which is the ambient temperature correction factors based on the 30 degrees Celsius. Okay, so yan makikita natin na dito yung ambient temperature. So temperature rating of conductor, meron tayong 60 degrees, 75, and 90 degrees Celsius. And of course, the ambient temperature in degree Fahrenheit. Okay, next, this table shows what could be the size of our wires that we are going to use, especially when it is direct or exposed to sunlight, or when it is located on above our rooftops. So, syempre, ito ay ginagamit. Ano ba yung mga klase ng wires na dapat gamitin sa ating mga solar-powered home? Okay, so let's proceed on the steps in PV system conductor sizing. Okay, so the first step is look for the ISC rating of PV cell. Next is multiply by 2 safety factors, irradiance, and continuous duty. Third, refer on table 310.15, B16 for the size of wires. And then refer also on table 310.15, B2A for, para naman malaman natin yung ampacity correction due to ambient temperature more than 300 degrees Celsius. And then for the fifth step is refer on table 310.15, the B3C for ambient temperature adjustment due to conduit or wire distance from the roof. And then refer on table 310.15, B3A for the adjustment due to more than 3 wires inside a conduit. And then for our seventh step, find the adjustment due to voltage drop, and then last is the value obtained in the last step will be the basis for the wire due to the PV system. Okay, so para mas maintindihan natin yung mga steps kanina, this is sample problem in PV system conductor sizing. Okay. So, ang problem natin dito is find the proper wire size for a grid-tied PV system consisting of 3 GA solar panels connected in series with specs at the previous slide. So, na-discuss nila yung mga specs ng mga gamit like GA solar panels, okay? So, step 1, ang sabi kanina is look for the ISC rating of PV cell. So, sinabi kanina na ang rating daw ay, or the ISC rating daw is 9.75 and ampere is equal to IPV. Okay, so step 2, multiply by 2 factors, irradiance and continuous duty. So, yung IPV natin is equal to 9.75 ampere times 1.25 times 1. Okay, so 1.25 is equal to 15.23 ampere. Okay, so after that, we are going to move forward on step 3, kung saan sabi we are going to refer or titingnan natin yung table 310.15 B16 para mahalaman natin yung mga sizes ng wire. So, the table indicates that number 14 THHN with an ampacity of 25 amperes, yun lang daw ang gagamitin natin. Okay, so since number 14 AWG is not the best practice for PV system, we are going to use the number 12 THHN with an ampacity of 30 amperes. Okay, so ang sabi natin, di ba, is find the proper wire size for a grid-type PV system consisting of 3 GA solar panels connected daw in series with specs. Okay, with specs at the next slide natin. Okay, so the step 4 is ampacity correction due to ambient temperature. Okay? Okay, so step 4, sabi dito, ampacity correction due to ambient temperature. So, dito kasi sa Pilipinas, or sabi dito, since Philippines ambient temperature is around 37 degrees Celsius, so pupunta tayo sa table. Okay? So, sa table, sinasabi doon na 30 times 0.91 is equal to 27 amperes. Okay, so moving forward to step 5, which is the ambient temperature adjustment due to roof, wire distance for one half in above roof, 37 plus 22 is equal to 59 degrees Celsius. So, the table 310.15 B2A indicates that 27 times 0.71 is equal to 9.17 ampere. So, since 19.71 ampere is greater than 15.23 ampere, our selected number 12 wire will fit this system. Okay, so ang hinahanap nga natin is what could be the proper wire size para sa ating grid-tied PV system consisting of 3 GA solar panels. Okay, so in our step 6, since there is only 2 wires inside the conduit, this step can now be passed. Okay, so sa step 7 naman, adjustment due to voltage drop, VT is less than 3%. So we are going to use the formula. VD is equal to 2IR, R is equal to K, open parenthesis, L over A. VD is equal to 2 times 9.3 times 12.9 times 25 over 6,530, which is equal to 0.92 volts. So, VD is equal to 0.92 over 32.26 times 100%, which is going to a total of 2.85 Okay, so since 2.85% is less than 3%, our selected wire is number 12, which can be fit into the system. Okay, so but since 2.85 is a bit near to 3, it would be better to use number 10 THHN wire for additional safety factor and for future expansion. So sabi nga, di ba, hindi naman kailangan na fit, sobrang fit doon sa ating mga wire yung gagamitin natin. Mas better kung mas mataba yung gagamitin natin para um, sa resistance or para na din. May sinasabi kasi tayo na characteristic ng wire, di ba? So, yung conductor sizing natin na ginagamit sa PV system, dapat yung kung ang characteristic ng wire, dapat mababa yung resistance. Kasi nga, di ba, kung mababa yung resistance ng wire, mas mababa dapat or mas mataba yung wire, meaning nami-minimize nun yung ating losses. So, sabi doon sa ating previous problem na in case the voltage drop exceeded 3%, sabihin natin na 5%, the additional computation is as follows. So, the initial selected wire is number 12 THHN. Make a one-step higher adjustment. So, mag-a-adjust tayo ng konti para magamit natin ng mas maayos yung wire natin. Select initially number 10 THHN. So, VD is equal to 2 times 9.3 times 12.9 times 25 over 10,380 is equal to 0.0058 volts. So, V sub D is equal to 0.058 over 32.26 times 100% is equal to 0.18%. So we are going to select the number 10 THHN as the final wire to be used in the system. Okay, so note, K is equal to direct current constant. This is a constant representing the direct current resistance for a 1,000 circular Mills conductor that is 1,000 feet long. At an operating temperature of 75 degrees Celsius, the direct current constant value you should use for copper is 12.9 ohms and 21.2 ohms for aluminum conductor. So, sabi dito, kapag ka daw sa mga copper yung gagamitin natin, dito dapat daw na 12.9 yung sa copper and then pag aluminum conductors naman is 21.2 ohms. So, the K constant is suitable for alternating current circuits where the conductors do not exceed number 1 over 0. Okay, so let's proceed on our DC circuit breaker sizing. Okay, there are things to consider para sa ating breaker sizing. First thing to consider in sizing a CV for a photovoltaic system is the ruling in PEC, which states that PV circuit current is continuous. Okay, thereby, the minimum OCP rating is 125% of the maximum current. So, makikita natin yan sa ating PEC 2017, Article 6.20.2.2 and Article 6.90.2.3. Therefore, in reference to the problem in conductor sizing, on the DC side, the max current is 15.23 ampere multiplied by 125%. So, the answer would be 19.04. So, gagamitin natin yung 25 ampere CV. On the AC side, let's assume that the inverter rating is 1.5 kilowatts. Multiplied by 125%, that is 15. So, ang gagamitin natin dito ay 20 ampere CV RCVO. Okay, so what are the rules in SPT sizing? The rule is simple in sizing of surge protection device. Basically, the UC rating of the SPD should match the system voltage or a bit higher, 15% to 25%. For SPDs to attain a longer lifespan. So, para daw, mas humaba yung buhay ng ating SPD. Therefore, in reference to the problem in conductor sizing, ano ba yung mga kailangan natin na meron tayong mga reference dito? Para daw sa ating DC side, use SPD with UC rating of 100 volts to 120 volts. So, para naman sa ating AC side, use SPD with UC rating of 230 volts to 275 volts. So, what are the SPD specs natin? So, IN is nominal discharge current. Max is maximum discharge current. Sa UC naman natin is maximum continuous operating voltage or the MCOV. So, UP is voltage protection rating or VPR or surge voltage rating or the clamping voltage. Okay, so on those country located at the northern hemisphere, solar panels should be facing south direction for maximum sunlight. So, yung mga countries daw na located sa northern hemisphere, kailangan kung magkakaroon sila ng mga solar panels, kailangan yung ano daw nun, yung location or yung solar panel nila is nakaharap doon sa south para mas makuha yung maximum na sunlight. While naman sa mga taga-southern hemisphere, kailangan naman is facing north sila para makapag-gather sila ng enough or yung maximum na sunlight. So, since Philippines is above equator, it belongs to the northern hemisphere. So, ano ba yung sabi kanina na kapag daw ang country ay nasa northern hemisphere, kailangan ang panel ay facing south. Okay? So, sabi dito, the solar panels should be facing south direction for maximum efficiency. A general rule for optimal annual energy production is to set the solar panel tilt angle equal to the So, a general rule for optimal annual energy production is to set the solar panel tilt angle equal to the geographical attitude. Essentially, the closer a panel is located to the equator, the more the panel should be pointing straight up. The closer the panel is to the poles, the more they should tilt forward to the equator. Therefore, in Philippines, the solar panel tilt should be 12 to 14 degree. So, kailangan yung yung panels natin, baba na siya. Okay? Sabi dito, 12 to 14 degree. Okay, let's see the zero bill computation. Okay, so we are going to compute the zero bill computation. Compute for your monthly average kilowatt per hour used. So, 300 kilowatt hour per month. Convert to daily usage, 300 kilowatt hour per month plus 30 days is equal to 10 kilowatt hour per day. So, it will be equal to 10,000 watts hour per day. So, tandaan natin na in Philippines, ang peak sun hours natin is equal to 5 hour. So, every day yan 5 hour. For solar array rating, 10,000 divided by 5 is equal to 2,000 watts. And para naman sa ating for zero bill assurance, 2,000 times 1.1 is equal to 2,200 watts. So, ang kailangan natin na panels ay 2,200. So, tandaan natin yung zero bill natin. Itong nandito zero bill natin tong 2,200. And then, yung 300 naman is yung ating monthly average. Okay, so we are going to divide this. 2,200 divided by 300 would be equal to 7.33. So, ilan daw yung kailangan natin na panels? Wala namang 7.33, diba? So, ito yun, magiging 8 solar panels daw para maging zero bill. Para wala tayong bayaran totally. Okay? So, this computation will help us para ma-determine natin kung ilan ba talaga yung kailangan na panels para magkaroon tayo ng zero bill sa ating solar-powered home. Okay, so that's all for today's video. I hope na may tutunan tayong lahat. And I hope na magamit natin ito sa future. Especially kapag mga naging engineers na tayo. And thank you, sir, for teaching us and for the another semester na nagkasama-sama tayo. So, this is What's Minay Group, the electric company, signing